product to sum and sum to product identities. The product to sum identities are used to rewrite the product between sine and cosines into a sum or difference. These identities are derived by adding or subtracting the sum and difference formulas for sine and cosine that were converted in an earlier section. For example, sine the quantity of A minus beta is equal to sine A cos beta minus cos A sine beta, and the quantity of A plus beta is equal to sine A cos beta plus cos A sine beta. If we were to subtract sine the quantity of A minus beta from sine the quantity of A plus beta, we could derive the product to sum identity. For the product of cos A cos beta is sine the quantity of A plus beta is equal to sine A cos beta plus cos A sine beta. Negative sine the quantity of A minus beta is equal to negative sine A cos B minus cos A sine beta. Sine the quantity of A plus beta is equal to sine A cos B plus cos A sine beta. Negative sine the quantity of A minus beta is equal to negative sine A cos B plus cos A sine B over sine the quantity of A plus B minus sine the quantity of A minus beta is equal to 0 plus 2 cos A sine B sine beta. 2 cos A sine beta is equal to sine the quantity of A plus beta minus sine the quantity of A minus beta. Now, multiply both sides of the equation by 1/2. So 1/2 times 2 cos A sine beta is equal to 1/2 sine times A plus beta is equal to sine times A minus beta. Cos A sine beta is equal to 1/2 sine the quantity of A plus beta minus sine the quantity of A minus beta. Product to sum identities. Sine A sine beta is equal to 1/2 cos the quantity of A minus beta minus cos the quantity of A plus beta. Cos A cos beta is equal to 1/2 cos the quantity of A minus beta plus cos the quantity of A plus beta. Sine A cos B is equal to 1/2 sine the quantity of A plus beta plus sine the quantity of A minus beta. Cos A sine beta is equal to 1/2 sine the quantity of A plus beta minus sine the quantity of A minus beta. Example, express the product of cos 3x cos 5x as a sum or difference. Solution. Identify which identity will be used. The given product is a product of two cosines. To the cos A cos beta identity will be used. Cos A cos beta is equal to 1/2 cos the quantity of A minus B plus cos the quantity of A plus B. So, this is the continuation of our example. Then apply the product to sum identity for cos A cos beta. A is equal to 3x and beta is equal to 5x. Cos A cos beta is equal to 1/2 cos the quantity of A minus beta plus cos A plus cos the quantity of A plus beta is equal to cosine 3x, cosine 5x is equal to 1/2 cosine the quantity of 3x minus 5x plus cosine the quantity of 3x plus 5x. Cosine 3x, cosine 5x is equal to 1/2 cos the quantity of negative 2x plus cosine the quantity of x 8x. Then apply the even or an odd identity for cosine the quantity of negative x. Cosine the quantity of negative x is equal to cosine x. Cosine 3x, cosine 5x is equal to 1 half cosine 2x plus cosine 8x. So, the purpose of the sum to product identities is to reverse of the product to sum identities. These identities are used to rewrite the sum or difference of sines and or cosines. In a product, if you wanted to verify the identity, we would use the product to sum identities. So, product to sum to product identities. Sin A plus sin beta is equal to sin A plus beta over 2 cosine A minus beta over 2. Sin A minus sin beta is equal to 2 sin A minus beta over 2 cosine A plus beta over 2. Cosine A plus cosine B is equal to 2 cosine A plus B over 2 and cosine A minus B over 2. Cosine A minus cosine beta is equal to negative 2 sine A plus beta over 2 and sine A minus beta is over 2. Example number 2. Express the difference of sine 2x in sine x as a product. So the solution is, first, identify which identity will be used. The given difference is the difference between two sines, so the sine A minus sine beta identity will be used. Sine A minus sine beta is equal to 2 sine A minus beta over 2 cosine A plus beta over 2. The continuation of example number 2. Then apply the sum to product identity for sine A sine B. A is equal to 2x and B is equal to x. Sine A minus sine beta is equal to 2 sine A minus beta over 2. Cosine A plus beta over 2 and then sine 2x, and then we distribute the 2x. So our A, the value of A is 2x. So sine 2x minus sine. So the value of beta is x. So minus negative sine x is equal to 2 sine 2x. Ato ang pong atong i-distribute ang value ni A and ni beta. 2x minus x over 2 cosine 2x plus x over 2. So the answer is sine 2x minus sine x is equal to 2 sine x over 2 cos 3x over 2. Example number 3. Verify the following identity. So sine 4x plus sine 6x over sine 4x minus sine 6x is equal to negative tan 5x cot tangent x. So, the solution is, first, apply the sum to product identity for sine A plus sine beta to the numerator. A is equal to 4x and B is equal to 6x. So, the formula is sine A plus sine beta is equal to 2 sine A plus beta over 2 and cosine A minus beta over 2. So, then distribute the value of A and beta. So, the sine A is equal to sine 4x plus then sine beta is equal to sine 6x minus 2 sine then A plus B. May muna siyang 4x plus 6x over 2. Then cosine A minus beta is equal to 4x minus 6x over 2. Sine 4x plus sine 6x is equal to 2 sine 5x cos the quantity of negative x. So, cosine the quantity of negative x is equal to cos x. So, the answer of our problem is sine 4x plus sine 6x is equal to 2 sine 5x plus cos x. So, this is the continuation of our example number 3. And then, apply the sum to product identity for sine E sine beta. So, this is the continuation. So, A is equal to 4x and B is equal to 6x. Sine A minus sine beta is equal to 2 sine A minus beta over 2. Then cosine A plus beta is equal to over 2. Then sine 4x is minus sine 6x is equal to 2 sine 4x minus 6x over 2. And cosine 4x plus 6x over 2. Then sine 4x minus sine 6x is equal to 2 sine the quantity of negative x cos 5x sine the quantity of negative x is equal to negative sine x. So the answer is sine 4x minus sine 6x is equal to negative 2 sine x cos 5x. Then substitute the product into the identity. Then sine 4x plus sine 6x over sine 4x minus sine 6x is equal to negative tan 5x cotangent x. So 2 sine 5x cosine x over negative 2 sine x cosine 5x is equal to negative tan 5x cotangent x. Then rearrange the factors, separate into individual fractions, and reduce. So 2 over negative 2 times 5 sine 5x over cosine 5x times cosine x over sine x. So is equal to negative tan 5x cotangent x. So the answer is negative tan 5x cotangent x is equal to negative tan 5x cotangent x.